Hello, viewers. In today's session, we are going to discuss an important problem related to Dirac Delta Function, right? So, in this class, we are going to find out the Laplace transform of functions involving the famous Dirac Delta Function. So, here we have to find the Laplace transform of this function, that is minus t cube and delta of minus 2t plus 1, right? So viewers, we have already solved a lot of problems in our earlier videos related to Dirac Delta Function, and in this session we'll solve this problem. So let us start. So let us first define the Laplace transform of a function f of t, right? So the definition of a Laplace transform of a function f of t is given by this integral 0 to infinity e raised to minus st, where s is the parameter which may be a real one or complex one, right? And here we have f of t, right? So this is the definition of Laplace transform of a function f of t, right? Now let us replace f of t by this function, right? So we'll take f of t as minus t cube and delta of minus 2t plus 1, right? So we have now Laplace transform of minus t cube delta of minus 2t plus 1 is equal to 0 to infinity e raised to minus s times t, and f of t is minus t cube delta of minus 2t plus 1, right? So here we have dt. So now we have to calculate or to compute this integral. So now let us rearrange the terms. So we can take this negative sign outside the integral. We have 0 to infinity. Then we have t cube, and then we have e raised to minus st, and here we have delta of minus 2t plus 1 dt, right? Okay, now to move further, what we will do, will make use of one important property of Dirac delta function, right? Now see, the property goes like this: if we have delta of, say, ax minus b, then we can write, if we take a common, then we have x minus b over a, right? So delta of ax minus b is equal to delta of a times x minus b over a, right? So if we take this a outside, then what we do, we write 1 over the mod of a, right? And we write delta of x minus b over a. So delta of ax minus b is equal to 1 over absolute value of a, and a is the coefficient of x, right? And x minus b over a. So we'll apply this property in this term, that is delta of minus 2t plus 1. So now this term, that is delta of minus 2t plus 1, can be written as delta of minus 2, and we have here t, because we are taking minus 2 common, so we have here t minus 1 over 2, right? So here the value of this a is a minus 2, right? So now applying this property, we can now write 1 over mod of minus 2, and we have delta of t minus half. So mod of minus 2 is positive 2, so we have 1 over 2, delta of t minus 1 over 2, right? So now this expression can be written as a negative. Then we have 0 to infinity, we have t cube e raised to minus s times t, and this term can be replaced by this one. So we have half and delta of t minus half, and here we have dt, right? Now we can take half outside the integral. We have minus 1 over 2, 0 to infinity. Then we have t cube e raised to minus st, and delta of t minus 1 over 2 dt, right? Okay, now see, here with the delta of t minus half, we have this function, right? So let us call this function as g of t, right? So we can now write minus half, 0 to infinity, and then we have g of t, because t cube times e raised to minus st can be taken as some function g of t, and here we have delta of t minus half, and here we have dt, right? So now we have a very simple integral here, because we can make use of the definition of Dirac delta function. The definition goes like this: if we have the integral minus infinity to positive infinity, and here we have some function, say f of x delta of x minus a dx, then the value of this integral is equal to the value of this function at this point, that is x is equal to a. So this is f of a, right? Because we know that here we have minus infinity, here we have plus infinity, and here we have x minus a, and this point, say it lies here, x is equal to a. So the delta function has the value at only this point, that is x is equal to a, right? And apart from x is equal to a, the delta function is 0 in the entire number line, that is minus infinity to a, and then a to infinity, right? So the value of the delta function, it exists only at this point, x is equal to a, right? Or in other words, we can say that this spike exists at only this point, x is equal to a. But here we have the limits, that is from 0 to infinity, right? Here we have 0, here we have infinity, and here we have delta of t minus half, right? So t minus half implies that we have the point t is equal to say half, right? So the delta function, it exists at only this point, that is t is equal to half. So our point A is the half here, right? So the value of this integral is now equal to minus half, and the value of the function g of t at this point, that is half, right? So we have g of half, right? So now we have to simply calculate the value of g of half. Now see, g of t is the function t cube e raised to minus s times t. So g of half is now equal to 1 over 2 raised to 3, and e raised to minus s times half, right? So now we have minus half, and g of half is now 1 over 2 cube is 1 over 8, and here we have e raised to minus s over 2, right? So this is 2 times 8 is 16, so we have minus 1 over 16 e raised to minus s over 2, right? So viewers, the Laplace transform of this function is equal to minus 1 over 16 times e raised to minus s over 2, which can also be written as minus 1 over 16 and e raised to s over 2.